Okay dears, now we can see that how the electric field will be produced due to an electric dipole at a point on its axial line. On its axial line means along the same axis. Here we are consider the electric dipole. One is plus q and another one is minus q. What is the dipole distance? 2a is here. At the point B, plus charge is there. At the point A, minus charge is there. Okay. Then what is the point we are going to take? From the midpoint of the electric dipole, we are taking the point that is nothing but C. It is at a distance of r. Okay, right. Then what are the essential things we have to note in this diagram? One is charge, okay, that is plus q. Another one is charge minus q at the point A. Now what will be the direction of dipole moment from minus q to plus q? That is represented here. Then the direction of electric field due to the positive charge is here, because due to the positive charge the electric field is always acting outwards. Okay, then due to the negative charge, here the negative charge is there, so that the electric field is always acting inwards. So here E minus is represented here. Okay, right. So this is the diagram. Now let us move to the description. Okay, here AB is the electric dipole on the axis, and then C is the midpoint. It is also already we have discussed. Then what is the electric field produced at the point C due to the positive charge? That is given by E plus equal to 1 by 4 pi epsilon naught into Q by BC square. Then this is nothing but, from the diagram I wrote, AB is nothing but what? Dipole plus Q and minus Q. And what is the midpoint distance? That is nothing but A. What is BC? BC is nothing but what? From the positive charge to C. So this distance R, this distance A. So to find this distance we have to subtract R minus A. That is I wrote there. Then from A to C, from A to C means from the negative charge to C we have to calculate. Okay, so from the negative charge here C, so up to distance R, this is A. That's why AC is equal to R plus A. But here BC is nothing but what? R minus A. That I wrote here. So you have to understand while preparing these values from the diagram. So this is the general formula for finding the electric field. E plus is equal to 1 by 4 pi epsilon naught Q divided by BC square along BC, where BC is nothing but distance. Okay, right. Then in the next step, the first equation is given by 1 by 4 pi epsilon naught Q divided by, instead of BC we are using the value R minus A whole square. The direction of electric field is always along BC. Why? Because it is the point B, it has the positive charge, the electric field is always acting outwards. So C is here, so the direction is given by acts along BC. Okay, but we are going to calculate the electric dipole. So dipole moment will be there because they are separated by a finite distance. Okay, so that I wrote here, since the electric dipole moment acts from the minus Q to plus Q, we are going to calculate the direction of electric dipole moment also. So that it is given by E plus is equal to 1 by 4 pi epsilon naught into Q divided by R minus A whole square into P cap. This is for the representation of unit vector, which is mentioning the direction. Okay, that is I wrote here, that is P vector is the electric dipole moment which is acting from the minus Q to plus Q. Okay, right. What is the next? Next step is nothing but we are going to calculate the electric field due to the negative charge. So what will be the negative charge? Only the distance will be different, remaining magnitude of charge is same. So that we can write E minus is equal to 1 by 4 pi epsilon naught into Q divided by R plus A whole square into P cap. What is a P cap? This is nothing but unit vector which is representing the direction of electric dipole moment acting from the negative charge to positive charge. Okay, it is also explained below this equation. Since the plus Q charge is very closer to point C than the minus charge, electric field due to the positive charge will be stronger. Why? Because the positive charge is very closer to the point C. Okay, so if we go through the diagram, we can understand that. Okay, what is the electric field due to the point charge? It is inversely proportional to the square of the distance between them. Already we have discussed, no, the same. So from the B to C, R is very less. So the electric field due to the positive charge is always high. A is far apart from the C. So distance value will be increased. Distance value increased means automatically electric field will be decreased. That is I wrote in that step. Are you clear? Now we can move to that topic. Okay, so after E minus I wrote some explanation for you. Okay, in that I mentioned the point charge plus Q is very closer to the point C than minus charge. E plus will be stronger, so that the resultant vector of electric field is acting along the greater magnitude. Therefore, E plus vector is drawn with large vector. Okay, where it is now we can go to the diagram. Okay, if you go through the diagram, you can understand that. Okay, where it is the distance. Now you can consider this distance and this distance. So E plus it is higher. That's why I wrote, because E plus is very closer to the point C. So the electric field it is also stronger than E minus. So that I wrote that point E plus is represented by the larger vector than E minus vector. Okay, now how can we calculate the resulting electric field? The resulting electric field, it can be calculated by only the superposition principle, because more than one point charge, that is electric dipole is there, so that we can use the electric dipole moment. Superposition principle. What is superposition principle? Superposition principle is equal to what? It is the algebraic sum of the electric field produced by the individual charges. Okay, right, now we can say that E plus is equal to what? 1 by 4 pi epsilon naught Q divided by R minus A whole square into P cap minus, for E minus we are writing here 1 by 4 pi epsilon naught Q divided by R plus A whole square into P cap. Okay, now by comparing these two relations, what are the common? 1 by 4 pi epsilon naught, so it can be taken out. Q is common, so it can be taken out. What will be remaining? What will be the remaining? Remaining is nothing but what? R minus A whole square, R plus A whole square. P cap is also common. Okay, so that the common terms it is brought out from the bracket. We can see that in the next topic. Next step. Now in this case, we can see that how it is simplified. So Q is brought out, 1 by 4 pi epsilon is brought out, P cap is also brought out. What will be the remaining? 1 by R minus A whole square. Then here 1 by R plus A whole square. Okay, now how can we simplify? We can take the cross multiplication. So R plus A whole square it will come to here, R minus A whole square come to here. Now we can use the formula A plus B whole square and A minus B whole square. Okay, that is explained in this step. Okay, how it is explained here? Here R plus A whole square, R square plus A square plus 2RA minus, it is separate term. Okay, that's why I mentioned in this bracket R square plus A square minus 2RA. When we multiply the minus into the bracket, then it will be minus R square minus A square minus of minus plus, so plus 2RA. Okay, then now we can take the common step. Okay, plus R square minus R square will be cancelled, plus A square minus A square will be cancelled. What will be the remaining? 2RA and another one 2RA. In denominator, R square minus A square whole square into P cap. It will be brought to the next step. So what is in the next step? Q by 4 pi epsilon, it is common. Then what is in numerator? 4RA, because 2RA plus 2RA was there. So total value 4RA. It is given here. Okay, right. Now in denominator it is given by r square minus a square whole square into p cap. The direction of electric field is always acting along BC because due to the plus charge only electric field will be maximum. Right. Now the net electric field acts along E plus because it is closer. Closer means distance will be less. Distance will be less means magnitude of electric field will be more. Okay, that is explained in this following diagram. What is the diagram here? Okay, right. Then I explained here, since C is very far apart from the dipole, C is very far apart, then we can compare the distance R and A, right? So A is very less distance, but R is longer distance. So when we compare the distance R and A, R is very greater than A, so that A can be neglected. Actually A square, change it A square. Because in 11th standard I explained clearly, when two quantities in a particular term is compared, if any one of them is very less, then higher powers of the smallest quantity can be neglected. While teaching the mathematical explanations, I have told clearly in 11th standard beginning of the class. Okay, so if we are comparing two quantities, we have to compare the distance, or we have to compare the quantity of or magnitude of two quantities. So here R is very large, A is very less. So higher powers of A, that is nothing but A square, it can be neglected. So what will be the remaining? R square will be there, whole square is there. R square whole square is equal to R power 4. That's why I wrote here R power 4. Okay. If we substitute R square minus A square whole square is equal to R power 4, then we will get this equation, that is 1 by 4 pi epsilon naught into, already 4A is there no in the numerator, 4RA into Q is brought into the bracket. Now 4RA into Q divided by R power 4, R, here R will be cancelled, so remaining what? In numerator 4AQ will be there, in denominator 1 R cancel, so remaining what? R cube is there. Now this term is, R can be rearranged as 4 can be divided into 2 into 2 into Q into A. So 2QA is nothing but what? Electric dipole moment into P cap is there, so that we can write P vector is equal to Q into 2A into P cap, that is equal to P vector. So 1 by 4 by epsilon naught it is there, R cube is there. Then in numerator only there is a change, that is nothing but these are all simplified as 2P vector. Okay, so this is the resultant electric field at the point C due to the electric dipole. Okay, right. Now what are the other important points we have to note from this axial line? Here from the diagram we can understand that both the electric field and the direction of electric dipole moment is acts in the same direction. If both are electric field and electric dipole moment, P vector and E vector is acting in the same direction, in same axis, then how can we say that it is the coaxial? Okay, so that I wrote here. So both vectors, electric field and electric dipole moment, they are coaxial. What is the angle between them? If it is coaxial means then angle between them is always equal to 0. Okay, otherwise we can understand from the diagram also. What is given in the diagram? Here we can understand that the direction of electric field, this is the two directions, one is dipole moment along this direction and electric field acting along this direction. Since both are acting along the same direction, we can say that both electric field and electric dipole moment, they are coaxial. Okay, it is mentioned here. If both are coaxial means the angle between them is always equal to 0. Right, one more point is there. Now we can see that point also. Right, so in this point what we are going to see, if the point C is taken left, of the dipole, what will be the direction of electric field? In that case also, electric field and dipole moment, it will act along the same direction. So you have to remember one thing. In the case of axial line, either the point is taken right of the dipole or left of the dipole, the resulting electric field is always acting along the direction of the electric dipole moment. Otherwise we can say that both the electric field and electric dipole moment, it will act along the same direction. Okay, are you clear? Right, this is important 5-mark question. 1-mark question also can be expected from this. Okay, right. Then we can see about electric field at a point due to the electric dipole along the equatorial line, we can discuss. Okay, right.